In previous videos, we have discussed many aspects of the distribution of discrete random variables. In this video, we'll talk about a particularly simple discrete random variable and its distribution. In this particularly simple discrete random variable is called a dummy variable, and the distribution of it is called Bernoulli distribution. So what is a dummy variable? A dummy variable is a random variable, it is a random variable that could take only one of the two values. The two values that it could take is 1 and 0. So a dummy variable could only take one of the two values, 1 or 0. And the value 1 of that variable typically indicates that an event occurs, while the value 0 indicates otherwise, in the case that the event does not occur. And because of this feature, a dummy variable is also called an indicator random variable, because it is a numerical indicator of some event. Just to give you a couple of examples, the dummy variable x equals 1 sub female is a dummy random variable that equals 1 if the randomly drawn individual is female, and that random variable equals 0 otherwise if the randomly drawn individual is not female. So in this example, we're considering the random experiment of drawing an individual from a population and observe the gender of the individual. And before we draw that individual and observe the gender, we do not know what gender that individual would have. And the possible values for the gender include female and not female. And if we define the random variable x to be 1, if the individual is female and 0 otherwise, then this x variable is a female dummy variable. And another notation for the female dummy variable is this 1 with the subscript female. Okay, this 1 with subscript female is a more specific notation for the female dummy variable. Of course, you could use the generic notation x, but it's more clear to use this more specific notation for this random variable. As a second example, the random variable x could be the indicator of a Biden win in the general election in November. And this random variable equals 1 if Biden wins the upcoming general election, and 0 otherwise. So this random variable equals 0 if Biden does not win the upcoming general election. So these are two examples of dummy variables. The distribution of a dummy random variable is a member of the Bernoulli family of distributions. So before defining the Bernoulli family of distributions, let's say a few words about a family of distributions. So what is the family of distribution? Well, it's like a family of people is a collection of people that share some common features, but are also different people. A family of distribution is similar. It is a collection of distributions of random variables that share some common features, share a common mathematical structure. Exactly what this mathematical structure is depends on the family, the particular family of distribution. We'll see a couple of examples of that. And the collection of distributions share this common mathematical structure, but the different distributions, different members in that collection are different from each other, and they are distinguished from each other by parameter, which is a number. Now let's define the Bernoulli family of distributions. A Bernoulli family of distributions is denoted Bernoulli P. So a member of the Bernoulli family distribution is denoted Bernoulli parentheses P. A random variable X follows a Bernoulli P distribution if it is a dummy random variable and the probability that X equals 1 equals P, and probability that X equals 0 is 1 minus P. So the Bernoulli family of distributions has the parameter P so this P is the parameter, and P takes value in the interval 0 to 1. And P is often called the success rate. Because Bernoulli distribution, any member of the Bernoulli distribution is a distribution of a dummy random variable, and dummy random variable indicates the occurrence of certain events. And suppose we say that the occurrence of an event is a success, then the occurrence rate, the P is the occurrence rate, is the probability that the event occurs, is the success rate. So just traditionally, we call this P parameter the success rate. So that's the Bernoulli family. So the Bernoulli, one Bernoulli distribution is written as Bernoulli P, and the Bernoulli family is the collection of all the Bernoulli distributions. So that is the Bernoulli family of distributions. And the distribution of a dummy random variable is a member of the Bernoulli family of distributions. So it is a Bernoulli distribution. The Bernoulli distribution can be described in a table as well. Just as any discrete distribution, it can be described in a table. The Bernoulli distribution has only two support points, 2 points in the support set, 1 and 0. And the probability mass function of the distribution is the probability that X, the random variable X equals each of the two values. So the Bernoulli P distribution can be described in the table like this, in this table. So that is the table representation of a Bernoulli P distribution. And if X is Bernoulli P, we know the whole distribution, the whole probability mass function of the random variable. We can calculate the expectation of the random variable. So expectation of the random variable is the weighted average of all the possible values weighted by the probability mass function. So it's P times 1 plus 1 minus P times 0. That gives us P. We can also calculate the variance of the Bernoulli distribution. The variance of the Bernoulli distribution can be calculated using the definition of variance, which is weighted average of the deviation from its mean squared. And if we plug in the E of X that we just calculated, so this is P times 1 minus P squared plus 1 minus P times P squared. To further simplify this, we can factor out this common multiplier P as well as the common multiplier 1 minus P. So we're left with 1 minus P plus P. 1 minus P plus P is 1. So in the end, we get P times 1 minus P. So the variance of a Bernoulli random variable is success rate times the failure rate, 1 minus the success rate. All right, so this two-value distribution is very easy to study, and there is not much to say about it. The last thing I want to talk about regarding Bernoulli random variables or dummy random variables is categorical random variables. Categorical random variables are random variables that sort outcomes into categories. So categorical variables is one that sorts outcomes into categories. Just to make it more concrete, let's consider an example. Let's say consider race. In a lot of the data sets about people, you might see a variable, a column of the data set that's entitled race. Race is a race categorical random variable. It sorts people, sorts individuals into different races, different categories. And possible values of race include, in the United States at least, include white, Black, Hispanic, and maybe there are some even more specific races. Let's say we don't name them, let's call all of them other. And they are a minority in the US population anyway. So this variable race, let's say it could take these 4 values, but these 4 values are not numerical. They are text, right? So they are not numerical. So technically, race is not a random variable. It's a categorical variable. It's a variable because it varies. Its value varies. But it's not in the mathematical sense a random variable because the values are not numerical, are not real values. Typically, when we use such a variable in our data analysis, we create dummy random variables based on the categorical variable. So how do we do this? Let's take this example. And we define random variables according to the values of this categorical variable. For example, we can define a random variable for white, a white dummy variable. The white dummy variable equals 1 for individuals whose race value is white, and 0 for the other values of race. And similarly, you can define a black dummy variable that equals 1 only when the race for that individual equals 1. And similarly, you can define a Hispanic dummy variable and another dummy variable. So these 4 dummy variables, they are numerical, they are random variables. Typically, these are the variables, the random variables that we use in data analysis. And that's how we utilize the information contained in a non-numerical categorical variable. Now, as one last bit of this lecture, I want to ask you to think about the following question, which I will not give you an answer. You can ask me during office hour or ask the TA to tell you the answer, but just to think about this question. Are these random variables, these dummy random variables that we just defined, are they independent? Well, you can answer this question by resorting to the definition of independent random variables. The answer should be straightforward.